Hi everyone, welcome to our Module 5, Operational Control, Part 5 of 8 Module Comprehensive Implementation Series of ISO 9001. We recommend that you start with Module 1, 2, 3, and 4 before you move to Module 5, and that will give you a comprehensive understanding and details that you might miss when you follow here. But you are welcome to proceed, and then later on you can review the other modules. Module 5, Operational Control, is built on the support infrastructure from Module 4. And this module is where your quality management system meets reality. And here I need to reiterate, we are using a case study company to give you a vivid picture of the operations and the implementation of ISO 9001 quality management system. So instead of explaining clouds only, we have incorporated real life case study, and we are going to dissect as usual and walk through the flow, give you a vivid picture of the implementation and the processes and the control and the operations. So you are going to learn from real life and not only explaining clouds. With that being said, let's proceed. So here you will learn to map and control your core operations with this Module 5. You will also learn how to manage suppliers, and you will learn how to ensure traceability effectively without any gaps. And then you will learn how to handle non-conforming products, because this module 5 operational control is where all our planning that we've done with in previous modules, including planning, leadership, and support system, will come together here in daily operations. And this module 5 of 8 module is a journey that we have designed this course to start from zero to ISO 9001 quality management system certifications and beyond. Beyond means we have planned other frameworks such as ISO 22000, ISO 14001, and ISO 45001 to be implemented. So Module 5 focuses on operational planning and control, and these processes uh, we need them for the provision of products and services. ISO 9001 Class 8 operation is the heart of the standards, as we all know, and is covering all the potential planning and control requirements. And this module provides practical implementation of operational control that ensures consistent quality delivery. Now let's have an overview of our case study company. Our case study company is named Global Meat House, and this type of organization, it handles meat slaughtering operations, secondary processing, packing, and export. The scale of our case study organization is between 200 to 500 employees across 2 operational sites. And the operational sites include Site A, which handle livestock reception operations, slaughtering processes, primary carcass handling, and initial chilling. Then we have Site B, which is 15 kilometers away from Site A. We handle secondary processing, cutting, deboning, portioning, packing, labeling, cold storage, and distribution. And the market reach for our organizations include local retailers, where we have also local retailers and wholesalers. We do have food services operators, including restaurants and hotels and butchers. And then we do have international export customers that include EU, Middle East, Asia, and US markets. And the key operational control challenge from Mutual 4 as following. And those are, well, are our objectives, which we are going to control today realistically in real life, and we are going to work through it. We are going to design and control effectively together. First challenge, we do have process variability, which is specifications conformance issues. And here, currently, our organizations from the gap analysis that we have conducted, we are currently at 94% conformance with 6% rework rates. We are targeting improvement of up to 98% conformance. The impact this issue is having on our organization include customer complaints and cost of poor quality. The second challenge is supplier control, which affects our quality consistency. And this is li- live animal quality variations that affect our quality products and contribute to specifications nonconformity. We will explain later and how to control it. And then we do have traceability gaps. Currently, we are at 8% traceability gaps per year. Our target is to conduct 100% traceability test success and sustain it that way through the implementation of effective ISO 9001. And we are going to show you how we can do that, and you can do it also with your organization. The other challenge we have is temperature excursions. Currently, our organization is having 12 incidents per year, and our target with the implementation of ISO 9001 quality management system is to ensure zero excursion per year and sustain it that way. We will also show you through this module how to do that and how to sustain it effectively. The impact this challenge is having on our organizations include product safety and cold chain integrity. The other challenge we are having is customer complaints. Currently, our organization is having 2.3% of shipment rates having customer complaint, and we are targeting less than 1.5% within the next 12 months. And the root cause of these customer complaints include specifications issue, documentation error, and quality inconsistency. And we are going to control all of that in this module. The other challenge we are having is export documentation error. Currently, our organization is at 93% accuracy rate with 7% error rate. We are targeting 99% accuracy. And the impact this challenge is having on our organization is shipment delays and customer satisfaction. And we are going to streamline that effectively on this module. Our goal with this module 5 is to transform the support infrastructure from module 4 into controlled, consistent operations that will address the 6 quality objectives, mainly reducing customer complaints from 2.3% to less than 1.5%, improving specifications from 94% to 98%, eliminate 12 annual temperature excursions, close 8 traceability gaps, improve export documentations from 93% to 99% accuracy, and reduce the 384,000 USD annual cost of poor quality by 30 to 50% within the next 18 months. This module provides the operational control system that turn our risk management plans and support infrastructure into reliable daily executions. Now let's have a recap of what we have learned so far from Module 1 to Module 2 to Module 3 and Module 4. In Module 1, which is understanding the organizations, we have covered the following. We have analyzed the context of the organizations, and that includes internal and external issues. We have also identified interested parties, covering customers, regulators, suppliers, and employees. We have also mapped our process approach from importing or receiving livestock to slaughtering operations to secondary processing and to distributions. And also we have defined the scope there covering 2 sites operations consisting 200 to 500 employees. And also we have established current performance baseline, which is at 384,000 USD of poor quality. cause of poor quality. Then in module 2, which is leadership and quality culture, we have covered the following. We have created leadership accountability metrics. We have established quality policy that covered animal welfare, cold chain, traceability, and export compliance. We have also in Module 2 set the objectives for quality with 6 key metrics targeting real performance gaps. Also interface control procedures of our 15-kilometer transport between Site A and Site B. And finally, in Module 2, we have established leadership routines that include daily, weekly, monthly, and quarterly routine of leadership. And then in Module 3, which is planning the quality management system, we have covered the following. We have established risk-based thinking framework. We have created risk register for all critical interfaces. And also we have linked our quality objectives to identified risks. And then we have also defined change management procedures. And finally, in Module 4, planning the quality management system, we have designed risk control to prevent the recurrences. And then in Module 4, which is support processes, we covered the following: resources and infrastructure management system, competence framework and training programs, communication system connecting sites, document control system operationalized, calibration and maintenance program. And that will bring us to today, operational control. Now we control the actual operation when we implement this module using all the infrastructure and systems that we have built. The infrastructure is ready if you implement all the previous module, and now with this module 5, we control the operations. Now let's see how each module supports the 6 quality objectives. First, we start with quality objectives of customer complaints. Currently, we are at 2.3% and we want to reduce to less than 1.5. Through Module 3, planning, risk identification for complaints issues, complaints causes have been identified, and we have identified there the root cause. And in Module 4, support, competent personnel and calibration equipment have been provided. Today in Module 3, operations, procedure control, not conformity management, and specifications compliance are going to be implemented. The second quality objectives is specifications conformance. Currently, our organization is at 94% and we are targeting 98%. Through Module 3 planning, risk assessment for specifications failures have been planned out. And in Module 4, training program measurement systems have been provided. Today, in operations in Module 5, process mapping, supplier control, raw material management, and rework reduction are going to be implemented. The third objective is quality of cost of poor quality, which is at 38 384,000 USD, and we want to reduce it by 30 to 50% within the next 18 months. Through Module 3 planning, opportunity identification for cost reduction have been planned and have been identified. And then through Module 4 support, resources optimization and waste reduction have been provided. And then in Module 5 operations today, nonconformity control, yield optimization, and rework minimization are going to be implemented, and we will do it together. The fourth objective, our quality objectives, is temperature excursions. Our organization currently is having 12 excursions per year, and we are targeting zero excursion per year. Through Model 3 planning, risk there is cold chain breakdown, which we have identified, and then in Module 4, which is support, preventative maintenance and monitoring equipment have been provided. Today, Module 5, temperature controls at all stages, transportation monitoring, and daily verifications are going to be implemented. Our fifth objective is traceability performance. Currently, our organization is having 8 gaps per year, and we are targeting 100% success rates of traceability test and sustain it, and we are going to do it together. Module 3, planning, risk have been identified, which is recall inability. In Module 4, support, traceability database and documentation system have been designed. Today, Module 5, operations, end-to-end identifications, monthly drills, 4-hour traceability, backward and forward capability are going to be implemented. Our last quality objectives, which is number 6, is export documentations error. Currently, our organization is at 93% accuracy rate, and we are targeting 99% accuracy rate. Through Module 3 planning, the risks have been identified as associated with shipment delays and regulatory issues. Through Module 4 support, document control, competence competent documentation staff have been provided. Today, with operations, labeling control, verification procedures, and traceability linkage will be implemented. So Module 5 represents the operational execution of everything planned in Module 3 and 4. The 6 quality objectives are now embedded in daily operations, ready to be measured in Module 6. This is where ISO meets reality in Module 5, is where our quality management system transitions from preparation to execution. Here in Module 5, we control the actual processes that transform live animals into quality meat products for local and export markets. This is where all our planning, leadership, support system, and infrastructure come together in daily operations. First, control core processes. We are going to map and control slaughter, processing, and packaging operations together today in Module 5. Secondly, we are going to manage suppliers by ensuring consistent quality from livestock sources. And we are going to enable traceability by tracking products from the farm to customer delivery. Module progression from support infrastructure to supplier control. Let's take a look. First, Module 4 support has covered the following: resources and infrastructure, competence and training, communication system, and document control. And then in Module 5 today, we are going to cover the following: process mapping and control, operational planning, supplier management, traceability, and identification. Then next in Module 6 performance, we will cover monitoring and measurement, internal audits, management review, and customer satisfaction. Module 4 provided the how infrastructure and systems are used. Module 5 provided the what the actual operations control that ensure consistency quality are delivered. Now, what is this model going to cover? Let's take a look together. This module implement ISO 9001 Class 8 operation through 6 key operational control areas, each addressing its specific subclasses of the standard. As we said earlier at the beginning of this training, we are not only explaining the classes, we are giving you real life examples. Here, let's walk through. The core operational console will cover the following: process mapping from slaughtering, processing, and packing, operational planning and control system, supplier control and evaluation program of the supplier, product identification and traceability systems, design and development controls for new products, if applicable, although we have excluded this step of design and development from our when we were writing our scope, but here we are including it in training for the training purposes so that you should know how to design and develop the new products. But in our case study, it's not applicable. Again, we are going to cover the following core operations control, non-conforming product control procedures, and we will do it in details together. And then also change management for operational modifications. If we look at our real world implementation, this module address actual operational challenge from 2 sites meet operations, including process consistency across shifts, livestock quality variation, rapid traceability requirements, and effective non-conformance product disposition. Participants, including yourself, will build practical control system that ensure consistent quality delivery from raw material to the final product, but in our case study, is from live animal to to packed product ready for local and international market. But if you are replicating this into your organization, which might be in different sector, just you should build the practical control system and replicate it to your organization from raw material to the final product and to the market that you go to. Here we will cover the import and export, the local and export market. By completing this module, we will have implemented the operational requirement of class 8. That means we will meet all the requirements. We will ensuring our processes are planned, controlled, and capable of consistently delivering conforming products and services. Now, operating without control are just activities. Control make them processes. And we have to know, this is the core message that we should always know. If we are going to operate, we should always have we should always have the support. And once we have the support, we have to ensure the control. If we don't have the control, even though we do have the support, we are just doing the activities and we are not making any process effective to eliminate the pain points. ISO 9001 Class 8 operations encompasses all operational planning and control requirements. This module addresses Class 8.1 operational planning and control, and also we will address Class 8.3, which is design and development. As we said, it's not applicable with our organization, but we will do it for the purpose of training. And then we will cover in this module class 8.4, which is control of external provided processes, and we will replicate that in our case study. We will replicate in laboratory, testing laboratories and transportation. And we will also cover in this module class 8.5, which is production and services provision, including class 8.5.1 control, and also class 8.5.2 identification and traceability, and class 8.5.3 property belong to customers or external providers, and clause 8.5.4 preservation, and then clause 8.5.5 post-delivery activity. And also we will cover clause 8.5.6 control of change. And then also in this module, we will cover clause 8.6 release of products and services. And we will cover clause 8.7, which is control of non-conforming outputs. We will cover it with real world example, and you will learn effectively how to implement it yourself in your organization. According to these clauses, organizations must plan, implement, and control the processes needed to meet the requirements for the provision of products and services. For our case study, Global Meat House, this means ensuring that every step from livestock reception to export delivery is controlled, monitored, and consistently executed according to the customer and regulatory requirements. This is where ISO meets reality, and this is how you meet the comprehensive requirement of ISO Clause 8 by transforming activities into controlled, measured, and improvable processes. Now, what operational control is and what operational control is not. Let's distinguish a difference here before we dive deeper and before we implement the comprehensive ISO Class 8. In ISO 9001 Class 8.1 Operational Planning and Control, it requires control conditions, not bureaucracy again, and understanding what operational control truly mean prevent common implementation mistakes. So it's essential that you understand what we are explaining here to distinguish between operational control and how to do it and how not to do it. First, operational control is the following. Operational control is plan and control execution. Operational control is consistent processes outcome. And operational control is proactive problem prevention. And operational control is measurable performance. However, operational control is not micromanagement. Operational control is not rigid procedures. And operational control is not reactive firefighting. And operational control is not excessive bureaucracy. By focusing on plan execution, consistent outcome, and proactive prevention rather than micromanagement and rigid procedures, you implement Clause 8.1 in a way that adds value rather than burden. Now, four pillars of ISO 9001 operational control. These pillars are what we are going to dissect and implement thoroughly through this module. First pillar, we do have process mapping and control, and that will fulfill and exceed the requirement of class 8.1 and 8.1.5.1, which is documented processes with defined inputs, outputs, and controls. The second pillar is supplier and external controls, and that will fulfill the requirement of clause 8.4, which is controls for external provided processes, products, and services. The third pillar is traceability and identification, and that will fulfill the requirement of clause 8.5.2, which is product tracking from source to customer delivery. Fourth pillar, we have non-conformance measurement, which fulfill clause 8.7, which is detection, containment, and disposition of non-conforming products. These four pillars collectively address the core requirements of ISO 9001 Class 8 operations, ensuring our processes are planned, controlled, and capable of consistently delivering conforming products and services. Now let's look at the first pillar, process mapping for the core operations, visualizing how workflow. ISO 9001 Clause 8.1 Operational Planning and Control requires organizations to plan, implement, and control the processes needed for the provision of products and services. What does that mean? Process mapping is the practice of visually representing how workflow through our organization from the input to the output. That means in simple language, you draw a process map how the product go from point A, point B, to point C, to point D. So from raw material to the final product. But this map also should include the responsibilities, should include decision points, should include system supports, and must include also requirements. For our case study, Global Meat House, this means mapping the complete flow from livestock reception from the farm to the point of packed product delivery to the customer. By documenting process flow with clear input, output, responsibilities, and decision points, we meet the requirements of ISO Class 8.1 for control, conditions, and processes implementation. The key principle here is process mapping help us identify all core processes and their dependencies, visualize responsibilities and resources, and highlight how each process contribute to delivering quality products and services. Now, let's see at the core process flow to two-side operations of our case study. And this you can replicate to your organization. Again, to remind the viewers, we are doing this of dissecting our organization and implementing from zero so that you can have a vivid picture of how to implement it. Then you can replicate and tailor it to your organization and have effective system. Let's do it. ISO 9001 class 8.1 class 8.5.1 control of product and services provision requires control conditions throughout production. This process flow that we are going to show you here demonstrate end-to-end control across both sides of our organization, which is Global Meat House. First, we start with livestock reception at site A. What do we do there? We have to map out animal welfare check, health certification, and holding procedures. Then the second map, the second process, we have to map out the slaughter operations inside A2, and that must include stunning, bleeding, evisceration, sorry, stunning, bleeding, evisceration, carcass inspection, and initial chilling. The third process that we need to map is the transport, 15 kilometers from site A to site B. When we are mapping this, we must also map the carcass loading, the temperature maintenance, and the documentation transfer. The fourth mapping we do have is process operation at site B. So after the transportation. This process mapping here must include the breaking of the meat, the cutting, the deboning, the portioning, and the specifications compliance. Then we must map the packing and labeling at site B. And these must include packing selection, labeling, weight verification, and case formation, sorry. Then cold storage and distribution at site B must be met. And these must include first in and first out or FIFO management, order picking, loading, and delivery documentation. This integrated process flow here meets Clause 8.5.1 requirements by defining control conditions, responsibilities, and handover points from livestock reception through final dispatch. Now, if you replicate this to your own organization, it will give you a vivid picture of what you need to control. The process control operations, ISO 9001, Clause 8.5, control of product and services provision requires availability of documented information, monitoring and measurement resources, competence personnel, and validation of processes. The following table that we are going to show you will demonstrate how each operations implement these controls conditions. Let's start with the process of livestock reception. The critical control point here is health certification, animal condition, and suppliers compliance. The monitor method in this process here is veterinary inspection, documentation review, and supplier scorecard. The control action required here is rejection, non-compliance, animals, and supplier feedback. Objective we are addressing with this process here is specifications conformance, which currently is at 94%, and we are targeting 98% accuracy. And then customer complaints, which currently at 2.3%, and we are targeting less than 1.5% improvement. The second process is slaughtering. The critical points here, critical control point, includes stunning effectiveness, bleeding completeness, and temperature control. The monitoring method we have for slaughter processes include visual inspection, time monitoring, and temperature logging. The control actions required for slaughter processes include re-stun if required, extend bleeding time if required, and temperature correction. The objective we are addressing with this process and controls include temperature excursion. Currently, our organization is having 12 issues per year, and we want to eliminate it to zero. and also the specification conformance is addressed through this process. The other process is secondary processing operation. The critical control point here include cut accuracy, weight specifications, and yield consistency. Monitoring methods include measurement verification, yield tracking, and rework monitoring. The control action we have for the processes operations process include adjust cutting, rework if needed, and process optimization. Quality objects we are addressing with this process of second processing operations is or include specifications conformance, and we need to reduce to 6% rework rate, and we need to reduce the 6% rework rate, and also reduction of cost of poor quality, which is at 384,000 USD currently. The other process is packing. The critical control point here with packing, we have weight accuracy, label correctness, and lot identification. Control measures include scale verification, label checking, and traceability verification. This is monitoring method, sorry. And then we do have the control measure. We do have reweight, correct label, and lot tracking. The objectives we are addressing with this process include export documentation error that we need to improve to 99% and traceability performance. Currently, our organization is having 8 gaps per year and we want to eliminate it to 0 per year. The other process is cold storage and transportation. Our critical control point for this process include temperature maintenance and documentation handover. The measurement method here, we do have continuous monitoring, transport log, and receiving verification. The control point, the control actions we are having here is temperature corrections and documentations completion. The objectives we are targeting here with this process include temperature excursions and traceability performance. These processes controls directly address the 6 quality objectives from Mutual 1 or Mutual 2, ensuring that operational execution delivers measurable improvement in customer satisfaction, specifications conformance, traceability, temperature control, documentation accuracy, and cost reduction. Supporting process integration. Cooperations depends on supporting processes that must be integrated and controlled to ensure consistent quality delivery. ISO 9001 Class 8.1 operational planning and control requires integration of support processes with operational process to achieve intended results. First, we do have to integrate maintenance and calibration by ensuring equipment availability and accuracy supporting production. The example of that will be daily chiller check before production starts. And then also we need to integrate training and competence by ensuring skilled operators executing process consistently. An example of that is competence verification before shift assignment. The third integration is quality assurance by ensuring testing and verification supporting process control. An example for that is pathogen testing supporting HACCP verification. By integrating quality control, maintenance, logistics, documentations, and training with core operations, we meet Clause 8.1 requirements for coordinated operational planning and control across the entire system. Integration principle here, supporting processes must be synchronized with core operations to prevent quality disruptions. 5.2 Operational Planning, the second pillar, controlling daily executions. ISO 9001 Clause 8.1 Operational Planning and Control, and Clause 8.5.1 Control of Production and Services Provision requires organizations to implement production and services provision under controls condition. Organizations must plan, implement, and control the processes needed to meet services and products requirements, ensuring that process is aligned with overall business strategy and that the quality management system is effectively integrated into business operations. First is product planning by ensuring schedule alignment with customer orders and process availability. Second, planning is process control. We have to ensure real time monitoring and adjustment of critical parameters accordingly. The third, planning and control, is resources allocation. We have to ensure assigning qualified personnel and verified equipment. Fourth, we have to ensure performance tracking by continuous monitoring against quality objectives and targets. By establishing daily production control system with clear criteria, monitoring and coordination between sites, we meet and exceed the requirement of clause 8.1 and 8.5.1 for controlled operational execution. The daily production control for two sites operations. ISO 9001 Clause 8.1 Operational Planning and Control and Clause 8.5 Control of Production and Services Provision requires daily operational control with defined criteria and monitoring. Now, this is how our daily production and control will go according to the design we are providing. First, with time. At 6, side A activity. In side A, we'll start with equipment startup, temperature verification, and side B will start with cold storage temperature check, and the control here is all systems must be within the parameters. The communication requirement here status report to production control. The objective impact of these control is temperature exposure elimination, and currently we are at 12 excursion per year, and we want to eliminate it to 0. Then at 7 a.m., site A activity will be livestock reception. They will start livestock reception. And site B activity will start with previous day's carcass reception from site A. And the control measure here include animal health verification, carcass inspection, and suppliers compliance check. The communication here will include transport coordination between site A and site B. The objectives we will impact with this control include specifications conformance, which currently we are at 94% and we want to raise it to 98%, and also traceability performance. And then at 8, side A, we'll start the slaughter operations, and side B will start processing operations from the carcass that they receive from side A. The control measures here include process parameters monitoring and yield tracking to be initiated. The communication protocol here include hourly production updates. Our objective targets here to control is customer complaints to reduce it to less than 1.5% and reduce cost of poor quality. Then at 12 midday, inside A, first carcass transport from side A to side B, and then inside B, midday yield review. The control measure here include transport temperature log verification and documentation handover. Communication protocol here include quality status update. The impact or the target objectives here to control is temperature excursion, export documentation error improvement from 93% to 99% accuracy. And then at 4 p.m. inside A, they will do daily production summary. Side B will start packing and labeling completion. And the control measure here include final weight verification and label accuracy check. The communication here is end-to-end, end of day reporting. And our target with this control is specifications conformance and export documentation. Then at 6 p.m., side A will clean up and shut down. Side B will conduct final dispatch operation to the markets. And the communication here, the controls include traceability verification and cold chain confirmation. The communication here includes daily performance review. Our target with this control is traceability performance, which currently at 8 gaps that we want to reduce to 0, and all objectives summary. This daily production control schedule directly support achievement of all 6 quality objectives by embedding objectives focused controls, monitoring, and communication into routine operations across both sites. Managing variability in raw material. Live animals vary in size, they vary in condition, and they vary in quality. Operational control must account for this natural variability while maintaining consistent output specifications. It seems like a challenge, but let's dissect that. This variability directly impacts the specification's conformance objectives. Currently, we are at 94% and we are targeting 98%, and contributes to the customer complaints rate, which currently at 2.3% and we are targeting less than 1.5% shipment. Managing inputs variability is essential to achieve these objectives. So ISO 9001 class 8.5.1 control of product and service provision requires control conditions even when inputs vary. So these particular critical in meat processing where raw material variability is inherent. So now let's try control here effectively and scientifically correct. First, animal assessment that must include weight range, conditions scoring, and breed characteristics affecting processing. Then, after the animal assessment, we'll move to process adjustment, and we must modify cutting patterns, process time, and handling methods based on the input variation from animal assessment. Once we have done the process adjustment, now the output optimization, we have to balance yield optimization with its specifications compliance for different markets. After the output optimizations, we have to verify the quality. And that means confirm final products will meet customer specifications despite input variability. So, the control principle here consistent outputs from variable inputs through adaptive process control, the adjustment, the modifications. Okay? This approach directly address the 6% rework rate at side B and reduce the 384,000 USD annual cost of poor quality by minimizing specification failures caused by raw material variability. So this process was not there last year, and now if we implement it effectively, we will eliminate the cause of poor quality and reduce the rework. By implementing grading system, acceptance criteria, process adjustment, and segregation protocols, we meet class 8.5.1 requirements while directly implementing specifications conformance from 94% to 98% and reducing customer complaints from 2.3% to less than 1.5%. These are two of the six critical quality objectives. Third pillar, supplier control and external provided processes. Controlling what we don't directly control. Seems complicated, but this is simple with ISO 9001, and let's do it together. ISO 9001 Class 8.4 Control of External Provided Processes, Products, and Services requires organizations to ensure that externally provided processes, product, and services conform to requirement. So organizations need to control around the activities that suppliers and contractors conduct at an operational level as details in ISO 9001 class 8.4 control of external provided processes, product and services. So what does this mean? What does this mean to us at Global Meat House? It means these include livestock suppliers, transport contractors, and laboratory testing services. The critical principle here, we are responsible for the quality of what suppliers provide, even though we don't directly control their processes. So, by implementing supplier evaluation, by implementing performance monitoring, by implementing verification procedures and contractual controls, we meet the requirement of Clause 8.4 for controlling external provided processes and products. Supplier control framework. Let's look at the framework, which is effective. In ISO 9001 Clause 8.4, control of external provided processes, products, and services, requires organizations to determine and apply controls to external provided processes, products, and services. The framework that we are going to show you now implement these requirements effectively. First, supplier evaluation must cover these points. First, initial capability assessment must be covered in supplier evaluation. Quality system verification must be covered in supplier evaluation. Facility audits, when required, must be covered during supplier evaluation. And finally, reference check and history of the supplier must be covered in supplier evaluation. That's one. Secondly, requirement definition for the supplier control framework must cover the following. First, clear specification and standards must be communicated. Quality and delivery requirements must be communicated. Documentation and certification needs must be communicated. And finally, under requirement definitions, communication and reporting requirements must be communicated. Fourth, in our supplier control framework, the third element is performance monitoring of our suppliers. Must include the following. First, regular performance review must be conducted. Quality metrics tracking must be maintained. Delivery and service performance must be monitored. And finally, issue resolution and improvement must be monitored. The fourth element of our supplier control framework include control actions, and these must cover the following. First, non-conformance management must be controlled. Corrective action requests, supplier improvement program, and alternative suppliers development. Those are control actions in our supplier control framework. Now, this supplier control framework meets Clause 8.4 requirements by establishing evaluation criteria, performance monitoring, verification methods, and continuous improvement mechanisms for all external provided processes and products. Now, let's look at the livestock supplier program. Effectively, and for you in your organization, you can tailor this to your raw material supplier. ISO 9001 clause 8.4.2 type and extent of control requires organizations to define control to be applied to external provided processes, products, and services. For livestock suppliers that we have in our case study, this is critical to product safety and quality. Now, let's look at the control area, the requirements, and the verification methods, as well as the performance measures and the objectives impact. First, let's start with animal health control area. The requirement here includes health certificate and vaccination records. And then, what is the verification methods for this control area? We include document verification and veterinary inspection. How do you measure this performance? It must be under 2% of rejection rate. And the objectives impact here, our quality objective impact, include specifications conformance that we need to improve to 98% currently, and customer complaints that we need to reduce to 1.5. The second control area is animal welfare. The requirement here is handling procedure and transport conditions. How do we verify this? Our method includes farm audit and transport inspection. How do we measure this performance? Our criteria is zero welfare violation. Okay, and the objective impact here is customer complaints, export documentations, regulatory which is regulatory compliance, and legally we are required to control this area with zero welfare violation. Third uh, control area is feed safety. The feed safety and the requirement for feed safety here include feed records, medications, withdrawal periods, and then the verification methods for this control area include documentation review and residue testing. The performance measure here, our KPI is zero residue violation. What objective are we impacting with this control measure? We are impacting customer complaints reduction, export documentations error improvement, and currently we are targeting 99% accuracy. And then we do have traceability. Okay, so traceability as a control area, and here the requirement for this area is include the following: individual animal identification and source from source farm documentation and individual animal identification. Those are our requirements. So the verification method here include we need to verify the ID of the animals at the reception and the link to the database of the documentation from the source farm and also downstream. And our KPI here is 100% traceable to the source farm. We have to make sure everything is linked. So what objective are we impacting with this control? Include one, traceability performance. Currently, our organization is having 8 gaps per year, and we want to improve that to 100% traceability success. The final area is quality consistency. The requirement here include animal size, animal condition standards, and breeding specifications. Our control measures here include visual inspection or visual assessment, and then grading at the reception. Our KPI here to control this is consistent quality supporting more than 98% conformance target. And the objective we are impacting here is specifications conformance and cost of core quality reduction, which is currently at 384,000 USD annually. Now, this livestock supplier control program meets clause 8.4.2 requirements while directly supporting 4 of the 6 quality objectives, namely specification conformance, customer complaints reduction, traceability performance, and export documentation accuracy. Effective supplier control is fundamental to achieving these objectives. So I hope now you can replicate this into your own organization. And don't forget to subscribe to our YouTube channel. We can send you this presentation later on. Supplier development. We need to work with suppliers or with farmers to improve compliance, and rather than just simply changing suppliers when problem occur. Remember from our last module, we talked about risk comes with opportunities, and with supplier risk comes supplier development as an opportunity to create stability. Now, for the service control service providers, let's see the control measures. Let's effectively implement that. First, According to ISO 9001 Class 8.4, control of externally provided processes, products, and services applies to service providers whose activities directly affect product quality, such as transport, maintenance, and laboratory services. Transport First, let's look at the transport contractors. The control measures here must include the following: one, temperature control capability; two, delivery training and competence; three, vehicle sanitation procedures; and fourth, emergency response capabilities. The second, service provider, which is laboratory service, the control must include the following: one, accreditation and scope; second, sample handling procedures; third, reporting timeline and accuracy; and fourth, control and proficiency testing. Then the service providers or maintenance contractors, the control elements must include the following: technical competence and certifications, spare parts availability, response time commitment, and food safety awareness training. By establishing capabilities requirements, qualifications criteria, performance monitoring, and contractual control for services providers, we meet Class 8.4 requirements for controlling externally provided processes that impact product conformity. Now, our fourth pillar: product identification and traceability, tracking from farm to customer. Let's do it effectively together. ISO 9001 Class 8.5.2 identification and traceability requires organizations to use suitable means to identify outputs when necessary, to ensure conformity, and to control the unique identification of output when traceability is a requirement. Now, organizations uh, must use suitable means to identify output when it is necessary to ensure conformity of products and services. So, when traceability is a requirement, organizations must control the unique identification of outputs and retain documented information necessary to enable traceability. So, for don't worry about this, I'm going to explain more. For meat operations, traceability is both a customer requirement and a regulatory operations. Now, this is just a summary, but we are going to walk through it now to implement it in real life. Now, by implementing systematic identification at each stage, maintenance traceability records, and enabling rapid trace forward and backward capability, you meet and exceed the requirement of Class 8.5.2 for product identification and traceability. The target performance is to reduce traceability time from 5 days to 2 hours for complete traceability of any product's batch from any stage of the product back to the source animal. Now, traceability system design. How do you design it effectively? Everything we just said now, faster, let's implement it in real life. ISO 9001 Class 8.5.2 identification and traceability requires organizations to identify outputs by suitable means and control the unique identification when traceability is requirement. In meat processing, traceability is both regulatory and customer requirements. This system directly addresses the traceability performance objectives that we have already identified in the previous modules, reducing traceability gaps from 8 incidents per year to 100% traceability test success through monthly traceability drill and systematic identification at every stage. Now, let's do it. First, what do you do when you are designing the traceability system? Animal identification. That must include and that must ensure individual air tag linking to farm source and production records. This is a foundation for zero traceability gap. This is the first step. Secondly, what do you do? Carcass tracking. And this must ensure unique carcass number linking animal source and processing batch. And this will enable rapid traceback capability. Thirdly, what do you do after the carcass tracking? Processing batch control. And you must ensure here batch numbers are linking multiple carcasses processes together. This will support a monthly traceability drill that we have designed to do and will support the verification. Fourthly, packing identification. So you have to include here product code that must link finished product to processing batch and sources. And this will achieve 100% traceability target. So this traceability system design meets class 8.5.2 requirements while achieving the traceability performance objectives of eliminating 8 annual traceability gaps and reaching 100% traceability test success. This system also supports the export documentation objectives of raising to 99% accuracy by ensuring accurate product identification and documentation. Now, traceability information flow. How does it flow in real life? According to ISO class 8.5.2, identification and traceability, it requires maintaining documented information to enable traceability. And the table below is going to show us information flow at each stage in our case study. First stage, farm source, identification, animal air tag. Key information requires there uh, farm origin, birth date, and health history. The link that we need to improve to include there is farm record system. Retention of these records, 3 years. Objective contribution of this record is foundation for 100% traceability test success that we are aiming. The second stage is slaughtering at site A. Identification needed here. Carcass number. The key information to be included, the slaughter date and inspection results. The link here must be linked to animal air tag and then to carcass number. And the retention time of this information is 3 years. And the objective contribution here is eliminating traceability gaps at site A. And then the third stage, processing at site B. Identification needed here is production batch number. And the key information that must be included here include process date, operator's name or operator's track ID, and then the yield date. And the link here, it must be linked to carcass number, that must link to batch number. And the retention of this information is 3 years. An objective contribution of this control is maintaining traceability cross-site handover, which is critical for gap area. The other stage, which is tracking. Here, the identification required is product lot code. And key information that must be included in product lot code include pack date, use by date, and packaging size. And the linkage that must exist here is batch number must be linked to lot code. And the retention of this information is 3 years. And the objectives contribution of these uh, include it will enable rapid customer to farm track back and also will support export documentation, which we are raising to 99% accuracy. Now, system requirement here. Any product lot code must track back to source farm within 2 hours, supporting monthly traceability drill. This capability directly achieves the traceability performance objectives of eliminating 8 annual traceability gaps and reach 100% traceability tests. Remember, you see how easy you can do it? I told you that we were going to do it. Now, This traceability information flow meets class 8.5.2 requirements while directly achieving the traceability performance objective, which are 8 gaps, and we need to eliminate that for 100% success, and supporting the export documentation objectives, which we want to raise to 99% accuracy through accurate product identification and documentation at every stage. Now, let's see the digital versus paper traceability. Now, in ISO 9001 class 8.5.2, identification and traceability does not mandate digital system but requires effective traceability, right? So, organizations must choose systems that are appropriate to their scale and complexity. So feel free to use any type of traceability, either paper, analog, or digital, but use it according to what you can manage. And here we will show you the difference and the preferences. Now, let us start with digital traceability benefits. The benefit of using digital traceability will include the following. First, real-time data capture and linking. Second, instant traceback capability. Third, integration with other systems. Fourth, automated alert and reporting. The example of digital traceability benefits here include barcode scanning, links carcass to animal automatically, right? Now, let's look at the paper traceability, the challenge. Challenge of paper-based traceability here are four. And we must remember, nowadays you have a lot of software that you can implement very affordably the digital traceability. Now let's look at the paper-based challenge. The challenge include the following of the paper-based traceability: manual data entry and linking, time-consuming trace investigation. Third, risk of human error. Fourth, limited integration capabilities. Example of paper-based challenge include manual lookup through multiple paper records that can take more than 2 hours. That is our target, right? Now, whether it's a digital or a paper-based, whatever traceability system you are using, you are meeting regardless of that, you are meeting class 8.5.2 requirements if your system enables rapid identification, maintain accurate records, and supports recall capability. Remember that. So digital systems typically provide faster response and better data integrity for multi-site operations or complex operations. Now, 5.5, design and development control if applicable. And as we mentioned earlier, this is not applicable for our case study, but we are conducting it here for training purposes and for you to benefit from it if you are doing design and development. Now, managing new products and processes change. ISO 9001 Class 8.3, Design and Development of Products and Services, requires organizations to establish, implement, and maintain design and development processes that is appropriate to ensure the subsequent provision of products and services. So, organizations must establish, implement, and maintain a design and development process to ensure the subsequent provision of the products and services. And for our global meat house, this applies to new product development, new cut, new packing, for example, or new packing format, processes modifications, or customer specific requirements. Now, let's break it down to look at it one by one. New product development. What must it cover? Wherever it's implementing, it must cover the following. If you are implementing a new product development, it must cover one, customer specifications analysis, two, process capability assessment of your organization, three, trail product and validation. Before you roll out, you must conduct the trail and validation. And fourth, the documentation and training. Then, if you have process change, you must include the following point. One, change impact assessment must be done before you design and develop uh, any changes. Okay, so just give me a second here. The second part is risk evaluation and mitigation. The third part is validation and verification. The fourth element is changing control and documentation. So you must ensure this. If you are implementing customer specific development, you must control it this way. Number one, requirement review and feasibility. Number two, processes adaptation planning. And number three, quality system integration. And number four, customer approval and sign off. Now, by implementing structured design planning, input output control, reviews, verification, validation, and change management, you meet the requirement of clause 8.3 for design and development control. And you must note here, this clause is only applicable if your organization is responsible for designing new product or services. Now, design and development process flow. This is how it happened in real life. ISO 9001 class 8.3 design and development of products and services requires a systematic approach to design and development. This includes planning according to class 8.3.2, inputs according to class 8.3.3, control according to class 8.3.4, outputs according to class 8.3.5, and change according to class 8.3.6. Let's begin. Let's begin developing and design process flow. First, design the planning. Design planning. In design planning, you must cover the following: define the scope, resources, responsibilities, and timeline for development project. And once you have done with that, you have to move to design input, which must include the following: customer specifications definition and regulatory requirements and process capability and quality standards. Once you have designed all this input, then you will move to design control, and you must cover the following: review gates, risk assessment, change control, and document requirement. And after that, once you are done with design control, you will move to design output, which must include process procedure, work instructions, quality specifications, and training materials. Once you are done with design outputs, then you move to design verification, which must include the following: confirm design outputs meets design inputs through trial and testing, like we said earlier. You must test before you roll out. Once you are done with the verification, then the design validation, which must include confirm the product meets customer requirements through full scale production. Now, this design and development process flow meets class 8.3 requirement, of course, by establishing systematic planning, define inputs and outputs, review and verification stage, validation activities, and change control procedure. Again, we must note here, this class only apply if your organization design new product or processes. 5.6, control of not conforming products. In control of non-conforming products, dealing with products that don't meet requirements, ISO 9001 class 8.7 control of non-conforming outputs requires organizations to ensure that outputs that do not conform to the requirements are identified and controlled to prevent their unintended use or delivery. This is very important. So organizations must ensure that outputs that do not conform to their requirements are identified and are controlled to prevent their unintended use or delivery. For meat operation, this includes products that don't meet weight specifications or have quality defects or fail microbiological tests. Now, this is how you control the non-conforming products. Number one, detection and identification. Okay. Now, this is the first stage you must start your control with. How non-conforming products are discovered and clearly marked. You have to lay this out and implement it effectively. Secondly, after detection and identification, you move to segregation and containment. And here, this stage includes physical segregation to prevent unintended use, like I just said, or ship it to customers. And after detection and identification, then segregation and containment, you move to evaluation and disposition. And in this stage here, include decision on corrective actions. Are you going to rework? Are you going to regrade it, upgrade or downgrade? Are you going to dispose it? Or are you going to accept with concession? The decision will be made according to predefined, according to the requirements. And once you are done with evaluation and disposition, then you carry out the corrective actions. And corrective actions mean implementation of approved disposition and verification of effectiveness. Either it's rework, dispose, acceptance, or regrade. Now, by implementing immediate containment, documented evaluation, corrective action, and verification procedure for non-conforming product, you meet the requirement of class 8.7 for controlling non-conforming outputs and preventing their unintended use. I hope that was clear. Now, non-conforming products category, let's categorize it here and see how we handle them. And we are going to do it according to ISO um, Class 8.7 Control of Nonconformity Output. It requires organizations to identify and control nonconforming outputs to prevent unintended use or delivery. Understanding nonconformity categories will help us to determine appropriate control when it occurs in real life. So let's take notes. First, nonconformity type. If it's weight specification nonconformity, what do we do? First example of that is over or underweight packing. The typical disposition for such nonconformity type is reweight or repack. The authority level for this nonconformity type is packaging supervisor. The objective impact with this control measure is include specifications conformance, customer complaints, cause of poor quality reduction through rework elimination. Second, nonconformity type is visual defects. Example of this could be bruising, discolorating, or trim issues. Typical disposition for this nonconformity type is regrade to lower specifications. The authority level here is quality supervisor, and the objective impact here is customer complaints reduction, specifications conformance improvement, and cost of poor quality reduction through downgrading, which reduce the revenue. Now, the other type of nonconformity is labeling error. The example of this is wrong date, product code, missing information, wrong language, and all that. Now, uh, uh, the typical disposition here is relabel with correct information, and the decision authority here is packing supervisor. The authority level is packing supervisor, and the target impact here is on our objective is export documentation accuracy improvement, traceability performance, and customer complaints reduction. And then we do have temperature Excursion as another type of nonconformity. Example of that is product of above 4 Celsius during storage or during transportation. Uh, the typical disposition here is hold the pending evaluation or potential disposal. The authority level here, including quality manager or plus management. The impact here on our objectives include temperature excursion elimination. Currently, we are having 12, we are targeting 0, and then cost of poor quality reduction, and then customer complaints reduction. The other type of non-conformance, we do have uh, traceability failure. Example of this is missing of lot code or broken documentation chain. Typical disposition here is complete documentation or verified traceability. And the level of authority here is quality manager. The impact of our objective here is traceability performance, which currently we are targeting 100% success and also improving accuracy rate for the export documentation. Now, by categorizing nonconformities and controlling them systematically, we meet Class 8.7 requirements while directly reducing the impact on all 6 quality objectives. Effective nonconformance control is essential to achieving the 384 USD dollar cost of poor quality reduction target and improve customer satisfaction from 97.7 to 98.5. Now, non-conforming product control procedures or processes. Clause ISO 9001 Clause 8.7.1 control of non-conforming output requires organizations to take appropriate actions to control and correct nonconformities and deal with consequences. So, this process below will implement these requirements. Effective nonconformity control directly impact multiple quality objectives, including reducing customer complaints, improving specifications conformance, and reducing cost of poor quality, which we set respectively. So, first, immediate containment of control. In our control process, we start with immediate containment is to stop further processing and segregate effective product. An example of this step is red tag and move to quarantine area to prevent customers' complaints by catching issues before the shipment. So this is our first in product control process, our first step. The second step, investigation. We will determine here the extent of problem and root cause. An example here is check other products from the same batch or the same operator and identify pattern affecting specifications, conformances, and cause of poor quality here. After the second step, which is investigation, we will move to disposition decision. Here we will decide what to do with non-conforming product. An example here is rework for different products specifications, which will minimize waste and cost of poor quality through optimal disposition. And the fourth element here in our control process is prevention action. And here we address root cause to prevent uh, recurrences. An example here is additional operational training or equipment calibration. Here, it will improve specification conformance from 94% to 98% by eliminating recurrency issues or recurring issues. Now, the time target. Initial containment within 30 minutes. This disposition decision within 4 hours for most not conformities. Rapid response prevent customer complaints and minimize cause of poor quality. This is very important note here. So this non-conforming product control process meets class 8.7 requirement while directly also supporting achievement of the specifications conformance, customer complaints reduction, and cost of poor quality objectives through the systematic detection, containment, and prevention. How module 5 uses module 4 to support infrastructure, or how module 5 uses module 4 support infrastructure. ISO 9001 class 7 support provides the foundation that enable class 8 operation here to function effectively. So module 5 establishes the infrastructure and module 4 puts it to work in daily operations. Now, Module 4 infrastructure, we have calibrated weight system that have been provided there. In operation here, what do we do with that uh, infrastructure? In operational control, packing weight control procedures to be implemented effectively. And daily implementation of this control here is operators must verify scale calibration before each shift and monitor packing weight. Secondly, training trained cutting personnel have been provided through the support from Module 4. What do we do here with operational control? Cutting specification control must be implemented, and the daily implementation and control of this is competent butchers must execute cutting procedures consistently to meet customer specifications. The third infrastructure that we get from Module 4 is site communication system. Module 5, operational control. Here, what do we do? Production coordination protocols must be implemented, and daily implementation control for this operation control include real-time coordination between sites to ensure a smooth carcass flow and processing. The fourth Module 4 infrastructure provided was document control system. In Module 5, operational control, we have to do the process control procedures effectively implemented, and daily implementation of this operational control include current procedures and work instructions guide daily operations consistently. Integration. Operational control built directly on support infrastructure, and without Module 4, Module 5 control would fail. So this integration demonstrates how Class 7 support and Class 8 operations work together. Support infrastructure enables operational control, and operational control validate that support infrastructure is adequate. Module 5 implementation outputs. You should have, after completing Module 5, the following. These outputs represent tangible evidence of ISO 9001 Class 8 operational implementation. More importantly, these outputs are operational mechanisms that deliver the six quality objectives established in Module 2. First output, process map and control. You should be able to conduct complete mapping of core operations from livestock to packing product, or in your case, it could be from raw material to final product, with defined control for each critical step. Include process flow, control points, monitoring methods, and corrective actions. Example in our case study include a slaughter map showing stunning control, bleeding time monitoring, and carcass inspection requirement. The objective addressed through this output here in our case study include specifications conformance. We are aiming 98%, customer complaints reduction less than 1.5%, cost of poor quality reduction currently at 384%. The second output, supplier control program. You must be able to conduct systematic approach to controlling external provided processes, including livestock supplier, in our case, transport contractors, and testing laboratories. Include evaluation criteria, performance monitoring, and improvement actions. Example in our case study, livestock supplier scorecard tracking animals, health compliance, welfare standards, and delivery performance. Objective addressed with this output of supplier control program includes specifications conformance, which is through consistent input quality, customer complaints through preventing supplier relating issues, and cause of poor quality through reducing supplier relating waste. The third output is traceability system. You should be able to conduct end-to-end product identification system, enabling rapid trace back from finished product to source animal, supporting both customer requirements and recall preparedness. Example here in our case study, digital traceability system linking product lot code to source from the source farm within 2 hours, supporting monthly traceability drill. The objective addressed here through this output of traceability system include traceability performance, currently at 8 gaps per year, and we are aiming to reduce it to 100% success of traceability drill, and also export documentation accuracy to above 99%. The fourth output, non-conformance product control. You must be able to conduct procedures for detecting, containing, evaluating, and dispositioning products that don't meet requirements, including authority level and time target for different type of nonconformities. Example, in our case study, red tag system for immediate identification and containment area for physical segregation. The objective addressed here through non-conforming product control output include customer complaints by preventing defects from reaching customers, specifications conformance by systematic corrections, cost of poor quality by minimizing waste and rework. The fifth output here is design and development control. You must be able to conduct systematic approach to new products, introductions, and process change that maintain quality while enabling innovation and customer responsiveness. Example here is new product development checklist. Example here is new product development checklist ensuring customer requirements are met and processes validated before launch. Objective addressed here through this output of design and development controls include specifications conformance by which new products meet requirements first time, customer complaints by validated processes to prevent issues, cause of poor quality by avoiding launch failure. These five implementation outputs provide auditable evidence of class 8 operations compliance while serving as the operational foundation for achieving all six quality objectives, namely customer complaints, specifications, conformance, cost of poor quality, temperature excursion, traceability performance, and export documentation accuracy. Executing your operational control. Implementation priority. This is how you prioritize control of your operations. First, core processes must be mapped and controlled. Implementation, sorry, executing your operational controls. Implementation priorities for operational control. First, core process mapping and control implementation. Second, critical supplier evaluation and control. Third, traceability systems activations. Fourth, non-conforming products containment procedures. And fifth is staff training on operational control procedures. And these are how this is the model of our training today. If you go back and you see, this is exactly how we implement it. Key success factors to make sure that your operational control is successful. First, focus on critical controls by control the processes that directly affect product quality and customer satisfaction first. Second, engage process operators. You must engage the people doing the work. Must uh, because people who are doing the work must understand and own the control procedures. Thirdly, balance control with flexibility. Controls should be robust enough to prevent problems, but at the same time, they must be flexible enough to handle normal variation. Fourthly, continuous improvement. Operational control need consistent attention and adjustment based on performance data. Now, common pitfall to avoid when implementing controls or operational control. First, what doesn't work in operational control? First, over controlling simple processes doesn't work at all. So keep it simple and straightforward. Second, rigid procedures that don't count for variation. This is useless and it creates rivalry from nowhere. Thirdly, control that operators can realistically follow. That means usually that's a symptom of copying from consultant without understanding what's going on. Don't do that. The ownership must be internally. You remember in our previous modules, we stressed that. Fourthly, what don't work? Reactive approach to nonconformities. No, everything happen, every nonconformity, every risk in mature systems, those are learning opportunities and things are taken constructively. Reactive approach to nonconformities doesn't help. Fourthly, paper-based system that is slow operations. We said it's affordable to have a digital base, especially for traceability. Six, ignoring suppliers' performance issues. In ethical organizations, this is a red flag. In other organizations that are less ethical, this is a common practice and it doesn't work. Now, what work? What does work? Number one, controlling critical quality characteristics is it work. Number two, flexible procedures that guide decision making. Number three, controls that operators understand and can execute. Number four, proactive prevention through good controls. Number five, systems that integrate with normal workflow. Number six, partnership approach with key suppliers. Now, your action plan to execute operational control. First, map current processes, and that should include document. You have to document how work actually flow through your operations today, and not the imaginary in the future and not the past. Just document the realistic one. Then identify critical control point, and here you will determine where controls are most needed to prevent quality problems. Then you can move to design control method here, and you will create practical, usable controls that operators can execute consistently and confidently. Then you move to the next stage, which is to test and refine before the rollout. Here, you will pilot the new control, gather the feedback, and then improve before the full deployment. Then deploy and monitor. After the validation, then you can implement controls systematically and monitor performance for continuous improvement. Preparing for Module 6 Performance Evaluation. Module 5 puts operational controls in place. Module 6 will show us how to ensure and evaluate their effectiveness. More especially, more specifically, Module 4 established the organization's control needed to achieve with 6 quality objectives. From Module 2, Module 6 will measure progress toward these objectives and drive continuous improvement. So ISO 9001 Class 8 operations established today the controls. Class 9, the next module, will establish the performance evaluation and will measure their effectiveness of today's operations and drive the improvement. So, what Module 5 has accomplished operational foundations for 6 objectives. One, core operational have been mapped and controlled. So, supports specifications conformance from 94 to 98 and customer complaints from 2.5% to less than 1.5%. Secondly, supplier control program operations have been operationalized, and that means support specifications, conformance, and cost of poor quality of 384,000 reduction. Product identification and traceability system have been implemented and will achieve traceability performance from 8 gaps per year to zero. And then non-conforming product control reduction procedures have been put in place to reduce customer complaints and cause of poor quality. And then temperature monitoring and control system have been implemented to eliminate temperature excursion, which are 12 annually currently. And then export documentation controls improve export documentation from 93% to 99 accuracy. And then what Module 6 will provide to us. Module 5 controls the operations. Module 6 will measure progress toward the 6 quality objectives. Firstly, we will cover monitoring and measurement, and under that, it consists process performance indicators, product quality metrics, and customer satisfaction tracking. And also, it will track the 6 quality objectives that we have been discussing here uh, through customer complaint rate, specifications, performance percentage, temperature exertion, traceability test results, and export documentation accuracy and cost of poor quality. Then it will cover internal audits, which will consist audit program planning, process-based auditing, final and follow-up um, finding and follow-up management, and verify. It will verify operational controls functioning as designed to achieve the 6 objectives. And then the management review, we will cover the management review, which will consist systematic performance evaluation, improvement decision making, resources allocation decisions, and review program toward the 6 quality objectives and makes decisions to accelerate improvement. And then we will cover customer specifications, so that will consist feedback collection methods, complaints handling procedures, uh, satisfaction improvement actions, and measurement customer complaints objectives from 2.3% to 1.5%, and overall satisfaction improvement. Now, the connection. Module 5, which is operations, that controls that enable objective achievement, and module 6, which is performance, and that's measurement of progress toward the six objectives. Operations without measurement are blind, so that's why we are implementing the next module. Module 6 provides the eye to see how your organization's controls are performing, right? So this progression from class 8 operations today to class 9 performance, the next module, ensures your operational controls don't just exist, they deliver measurable results and continuous improvement. Now, module 6 will show you exactly how to measure customer complaints, specifications conformance, uh, cause of poor quality, temperature excursion, traceability performance, and export documentation. So, operational control drives quality excellence. Good controls makes good results. That means if you control processes, outputs become consistent and predictable. And if outputs are consistent, customer receive quality they can count on. Now, your achievement with Module 5 so far: process mapping and operational control system have been implemented, supplier control and evaluation program operational, product identification and traceability system have been established, rapid trackback, and then non-conforming product control, preventing unintended use or delivery. So module 5, operations under control in our age module journey. Module 5 has transformed our support infrastructure from Module 4 into controlled, consistent operations. We have now the operational discipline needed to deliver quality product reliably across both sites, side A and side B. So from support to execution, operations control. With the operational control implemented in this module, our quality management system now controls the actual work that produces quality. We have moved from having the infrastructure to actually controlling operations. So what's next? Measuring performance uh, in module 6, which we covered earlier. So let's have the summary and the checklist for our module. Now, using this checklist to verify that you have implemented the key requirements of ISO 9001 Class 8. So make sure you go through this checklist. Each area directly supports achievement of the six quality objectives that we have established through module 1, 2, 3, 4. First, check the process mapping and control, and it must consist the following effectively: co-operational mapped, co-operational mapped from livestock to packaged products, critical control point identified and monitored, process controls integrated with supporting processes, control methods documented and implemented, objectives, specifications, conformance, and customer complaints and cause of poor quality. Okay. Now, the second, you should check uh, and make sure these have been implemented effectively, which is suppliers management. And it must consist supplier evaluation and selection criteria have been established, performance monitoring and control program have been implemented, requirements clearly communicated to suppliers, corrective actions and improvement processes are operationalized. The objective here is specification conformance by consisting output, uh, customer complaints from supplier quality, and cause of poor quality from supplier cost weight reduction. And then ensure that identification and traceability have been implemented effectively, and that must consist the following: product identification system from the farm to customer, traceability database enabling rapid traceback, documentation retention supporting traceability, system testing confirming traceback capability. Objective here is traceability performance, eliminating the 8 gaps, and export documentation accuracy improvement to 99%. Then ensure that non-conforming products have been implemented and consisting of the following: detection and identification procedures operational, segregation and containment methods have been implemented, disposition authorities and procedures have been defined, and prevention actions address root causes. The objectives here is customer complaints through prevention of defect reaching customers, specification conformance by systematic corrections, and cause of poor quality by minimizing waste, and temperature excursions, uh, which we have 12 incidents per year, and eliminating that through proper handling. By completing these 4 areas, you have implemented Class 8 operations requirements and established the operational foundation for achieving all 6 objectives. Our process now have controlled and capable of delivering measurable improvement in customer satisfaction, specification conformance, traceability, temperature control, and documentation accuracy and cost reduction. Are we ready for Class 6? If you check most of these boxes, you are ready to move forward. Model 6 will show you how to measure progress toward the 6 quality objectives and demonstrate continuous improvement. Operations without measurements are incomplete. So, Module 6 makes them measurable and accountable. Operations without measurable again are complete. So, now the complete journey where we are now today, just to highlight again, the module has been completed. Module 1, Class 4, Understanding the Organizations, which is foundations. We have established the foundation there and it covered. Context analysis have been complete. Process mapped. Scope defined. Performance baseline, 384 pay post course of poor quality. Module 2, Class 5, Leadership and Quality Culture. Accountability has been established there, and that include leadership structure have been defined, quality policy have been created, 6 quality objectives have been set, and interface ownership have been assigned. And then in module 3, which is class 6, planning the quality management system, risk management have been established there, and that includes risk-based thinking framework, risk register have been created, control have been designed, and change management procedures. Then we do have Module 4, Class 7 support processes, infrastructure have been established, and that include resources and maintenance system, competence and training program, communication channels, and document controls. Then we do have Module 5, Class 8 operational control, and operations have been controlled here, and that covered process mapping and control, supplier management and programs, traceability systems, non-conformity products control. The module ahead, we have module 6, performance evaluation, that will cover monitoring, measurement, audits, and management review. And then module 7, improvement, that will cover conformity, corrective actions, and continuous improvement. And then we have module 8, certification readiness, that will include gap assessment, audit preparedness, and certification. So far, we have progressed 62.5% completion, 5 of 8 modules. So you are controlled now, you have controlled the operations, and now you will measure and improve them in the next module. The foundation and operations are complete. Module 1 to 7 establish understanding, leadership, planning, support, and operational control. Module 6 to 8 measure performance, drive improvement, and achieve certification. Thank you for watching. Thank you for completing Module 5. And those are the achievements that you have conducted. I'm not going to repeat them again. Thank you. And please subscribe and stay with us. And this was presented to you by Wolbol, the founder of UHSC 300, sorry, the founder of UHSC 360, 360, I call it UHSC 360.org. Visit our website. We have free materials to give away. And we'll see you in the next module or module. I'll see you in the next module 6. All right. Thank you. Take care. God bless you. And thank you for keeping this world a safer place by building the best quality in your organization. We appreciate you. Bye.